part C.4, sort 4-element array. In this part, we will solve a simple problem, relatively simple problem, not too hard, but not very trivial. And the main idea we use to solve this problem, we need to use part of the insertion sort idea. Yeah. All right, so let's start. Look at this question first. Yeah. All right. So when we start, yeah. So the goal, sort and sort a full element array. All right, yeah. Let us represent this array as 4 elements. Yeah. x1, x2, x3, and x4. All right. First, let us try to understand this problem. You know, the understanding part can give us some mentally preparation. Yeah. All right, so first, the problem size n equals 4. Yeah. First, it is not a big number. Yeah. So not very hard, because when this problem size number bigger, then it is harder. Yeah. So not very hard first. Yeah. But second, this number 4, 1, 2, 3, 4, yeah. So from that point of view, 1, 2, 3, then 4. Okay? When n equals 4, there are 4 elements. That means it is non-trivial. Non-trivial. That means you really need to do some smart work to solve it. You cannot solve it in a trivial way. Yeah. You need to do some smart work. Yeah. Sort and 4-element array. Yeah. So this goal, yeah, let me complete. Yeah. Sort element array, we need another half of the sentence. We want to get, let me just continue that sentence, and get the best solution. Yeah. Otherwise, we are not satisfied. The problem size quite small. Why we do not get the best solution, right? Yeah, we should get the best solution for such a small problem, right? Yeah. So we want to get the best solution. The next question is how to understand this best solution. What is the exact meaning of the best solution? Yeah, we really need to understand the meaning here. Yeah. First, the best, we have another word for it, optimal, right? Optimal. Yeah. Optimal solution, that means nobody can improve it. Nobody can improve it. All right. Then, but there is another meaning behind it. Yeah. Based on my experience, many students get this part confused, get this best understanding not in the right way. Yeah. So here I really need to spend some time to explain its meaning, the best meaning here. When we look at the best case, worst case, many students get confused. First, best case and worst case. All right. Now, the main confusion is here. Main confusion is here. Yeah. Because many students, when they see the word best, they automatically connect to the best case. That is wrong. That is wrong. Yeah, I will explain why it is wrong. Okay, all right. So, quite some students, so not all, but that portion pretty significant. So many students automatically connect this best solution to best case. That is completely wrong. Yeah. All right, here, let me tell you why the best case. First, we know the best case is a special case, right? Special case. All right. If you solve this problem for the best case, you only solve the problem partially, right? Not completely. Because there are many other cases you have not considered. You have not considered. So you only solve one of the special cases. That does not mean you can solve the problem for all the cases, right? Yeah. And we want to solve the problem for all the cases. Yeah, all the cases. Only when you solve the problem for all the cases, then you can claim, I solved the problem completely. Yeah. Because in that way, you solve the problem completely. All right? So we want this, solve the problem completely, not partially. Completely, not partially. Yeah, not this case. Completely. Yeah. That means we should solve the worst case. All right? Yeah. Worst case because it is worst, right? If you can solve the problem for the worst case, then you can solve the problem only with better efficiency for all the cases, right? Because the worst case corresponds to the worst efficiency number, right? Worst efficiency number. That's the reason we call it worst case. Worst efficiency number. If you get the best solution for the worst case efficiency number, then for other cases, you can only do better than that, right? For other cases, you can only do better than that worst case efficiency number. Now, for that reason, actually, we should target the worst case. All right? Here, you can see, do not get this part confused. Yeah. So for this problem, we should get a best solution for the worst case. Actually, for all the cases, but the worst case here can cover all the cases. Yeah. Worst case, that efficiency number is the upper bound. Yeah, here, I use another word, upper bound for all the efficiency numbers. So try to understand in that way. Yeah. All right, so next. Now, let me update our goal. All right? Yeah. Based on the understanding of the previous page, let me update the current goal. Update. All right? Yeah. find the minimum, best solution. We should use the minimum number of comparisons, right? Comparisons to sort a 4-element array for the worst case. How about that? Find the minimum number of comparisons. This minimum connect to the best, right? How about that? Best case, best solution. But minimum number of comparisons to sort a 4-element array for the worst case. Now we make it explicitly for the worst case. Some students argue, so when I give the question, some students ask me to put the worst case explicitly. Although we can do it, but in the real world, you won't see it. People just ask you to sort a 4-element array with the best solution. So that's what people talk about in the real world. So that means even if I do not write it explicitly, for the worst case in this way, you should know you should target the worst case, best solution. All right, so here I spend a lot of time to explain that. All right. Next solution. For the solution, actually, we can do relatively fast because this question is not that hard. But when we work on it, let us use one commonly used strategy we used many, many times. Start with simpler cases. Start with simpler cases. So let us try when n equals 2, 3, and 4. How about that? 2, simplest. Because 1 trivial, we don't need to look at the n equals 1 case. So 2 is the first meaningful case. Then 3, second. The last one, 4. All right. Let's start. When n equals 2, that means there are, so first n equals 2, that means we only have 2 elements, right? Then one comparison, we get it sorted. Here, so this just, assumption, right? Although there are 2 different ways, but it is, good enough. One comparison, we can get the array sorted. Next, now n equals 3. One more element added. Think about, can we use the insertion idea? Here you can see the situation. We connect to the insertion sort idea. The third element, x1, x2, x3, the third element newly added. So we work on first 2 elements first, get it sorted with one comparison. Then we add a new element to the sorted array. How many more comparisons we need? Look at that. All right. insert new element x3 to already sorted array for the worst case. Remember, do not consider the best case. Best case, you only do one comparison. That's the best case. But here, you need to work on the worst case. So 2 more comparison. Yeah. 2 more comparisons. All right, yeah. 2 more comparisons, you get it sorted. Yeah. All right, so here, so let us assume x3 less than x1 less than x2. How about that? Okay, yeah. This is just a, representative. So we call it, this is a representative. Although there are, many other possibilities, we just select one as the representative. How about that? Okay, it's good enough. Yeah. But the number of comparisons, 1 plus 2 equals 3. All right, yeah, so the solution. 3-element array, we need 3 comparisons for the worst case, and this is the best solution. 3 comparisons to sort a 3-element array, the best solution we can get. Now, finally, we get to our last step. Last step, step 3. This time, our original problem, n equals 4. Okay, n equals 4, all right? Yeah. So now, our array x1, x2, x3, x4, can we use the insertion sort idea to insert new element x4 to the already sorted array x1, x2, x3. So that's the reason I put this example here, because it is closely related to the insertion sort. Next, the key step, the critical step, the key step. Now, all right, so look at our starting point. Suppose x1 less than x2 less than x3. Yeah, we use 3 comparisons to get the first 3 elements sorted. We just assume it is this case. Yeah. Now we want to insert the new element x4 to it. Yeah. But here, when we insert the 4th element, we want to do the best we can, right? The best we can. Here, we do not have to use the standard insertion sort. Yeah. So here, the key is do not have to use the standard insertion sort. We can modify it. We can modify it to get the best solution. All right, now let me show you the trick. Yeah, the key step. Yeah, when you do comparison, the first one you compare with x2 first. Do not compare x3 like what we did in the standard insertions. Compare with x2 first. That is, we use the idea of binary search, right? I believe you know a little bit about the binary search. Now, later we will study more about binary search, but here we need some basic idea of the binary search. Now, binary search, you compare the one element in the middle. You always compare the element 1 in the middle. So that is your first comparison, first new comparison. After that, based on greater than x2 or less than x2, you have 2 possibilities. Yeah. One is the second comparison you compare with x1, because x4 less than x2, so you need to compare with x1. Then another possibility, your second comparison could be compare it with x3, because x4 is greater than x2. Yeah. In both cases, you just need 2 more comparison, plus 2 more. Yeah. So with this binary search idea, you just, when you insert a new element, element number 4, you only need 2 more comparisons. All right. So finally, the best solution, 3 plus 2 equals 5. That is the best solution. Best solution. Okay? Yeah. Some of you probably want to ask, how do you know it's best, right? How do you know it is best? How do you show other people, how do you convince other people nobody can use 4 comparisons to sort 4 element array for the worst case? For the worst, how do you show that? Yeah. To show that, there is a way to do it. There is a way to do it. All right? Yeah. At some point, I may convince you, but we need to do some math. Yeah. But not here. Yeah. So later, I try to find a chance to show you we can show it. We can show nobody can use 4 comparisons to sort 4 element array for the worst case, not best case. Best case, yes. Yeah. But worst case, it's not. All right. So let us stop our C.4 video right here.